keep an eye on the time.
MicroCap by Tommy Strain and Josh Wagner. The problem. Microplastics are very hard to filter in tap water, and the average human consumes roughly about 5 grams of plastic a week, which is the equivalent of a credit card. Microplastics can have many health risks against the brain, placentas, and also in newborn babies. It also can reduce fertility and mess with hormones in adults.
Solution. MicroCap allows us to use a screw-on filtering clap to ensure clean bottled water. Filtration will be done by carbon filter, and the carbon filtration technology is 99.99% effective at filtering microplastics. This is because it has a 0.3 to 0.5 micron area which it can filter stuff through, and microplastics are usually 1 micron or bigger, which means it will effectively filter them. The creation of the MicroCap will be through CAD software and 3D printing, usually using Prusa and Fusion 360. And to keep the product reusable, we will have replaceable attachments as well as a portable case. Our design. So our design on the left, that's the basic prototypes, and that was basically used to size out the threadings in order to screw everything together. And on the right is our final design. And that's basically the big thing. You have the one thing that screws onto the top, the left screws onto the right, and you suck through it like a straw. Here's the main body of the MicroCap. So inside you have a little ledge, and that's where you actually place the filter. And then once you place this filter, you screw it onto a specified diameter threading on the bottom, and that lets you know which water bottles you can attach to. After you put the filtration in, you screw this attachment onto the top, which acts as a straw to enable you to suck water through the MicroCap and filter the water. However, there were a lot of shortcomings when it came to the MicroCap. We could not figure out which diameter threading to use to attach it to the water bottle because it's extremely difficult to accurately measure it, but we did do around 20 different 3D model tests in order to ensure a threading that would most accurately fit a water bottle. However, there's still a lot of testing that needs to be done in order to figure out one that is best for our MicroCap.
Our target audience is athletes, everyday citizens, and countries around the world to help provide clean water. Business plan. Taking the next step forward will require us to advertise and spread awareness about microplastics that have plagued tap water forever. Since our project is a profitable venture, we would also find a way to provide everyone with access to clean water once we become well known and have the funds to create our project and expand even further. Also, acquire knowledge through possible investors to propel our project forward. And here are some numbers. To get a filter pad, which can create about 30 filters for our water cap, 0.3 to 0.5 micron filter costs around $10, and the filament spool for 3D printing costs around $20. However, it only costs a couple cents to create our cap since we don't use as much filament. And we also plan to mill the cap in aluminum and microplastics, so microplastics aren't introduced by the filament. Experience and teamwork. What drove Josh and I to hopefully bring this project into fruition was that this topic of microplastics is barely researched. With our project, we will continue to scratch the surface and become more educated on this topic. Moreover, to understand this topic better, my partner and I would like to connect with experts to learn more about health risks and how to put our project on the market for the world to see. The overall experience of Capstone this semester gave us some insight on how to become organized and professional entrepreneurs when given the tools to showcase a project to a broad audience. Moreover, Capstone made us appreciate the process of designing a project that solves a world issue and having fun with each other's ideas to make our project better. Thank you for listening to us.